Hello, guys, and let me just start it off with saying that I'm dumb, right? I thought the day one was over, but there's actually the part two of day one, so I'm stupid for that, right? Anyways, we are going to do the part two, and I'm going to post it. It will be a short video, not that big or long of a video. We already have the algorithm of how to do it, right? This time, as I told last time in the video, passing through 0. So when it's 0 and passing through 0, we count it. Now first of all, go do it by yourself. Please don't watch my videos for doing this kind of stuff. If you're a beginner, just learn the algorithm and go and do it by yourself. Like what algorithm I'm going to use, it will be in the section. Go do it by yourself. Just to check answers, you can come later on, like if the way that you applied it is correct or not. I'm also a beginner. I don't know if I applied it in the best way possible or the fastest way possible, but I did get the answer. And the puzzle is just to do that. It's to like tickle your brain and get it good. You know what I mean? Anyways, so first of all, there are some changes that I've made to the code. Day one CPP, this right. So if we run it, it should get 1043. I won't run it like that. Last time I did that, it was problematic, right? Okay, I think, yeah, okay, I do have it 1043. Oh, sorry, yeah, okay, do one example, same thing, right? So now that I explain it, right, first thing that we do is the same as getting at point 0, right? We first of all do our dial, right? Okay, so if you actually see the example over here, you know this will be better to learn, right? Pointing at 0 at 50 actually, right? If the dial were pointing at 50, so the initial condition, and it was like r 1000, right? What would cause the, it would cause the dial to point at 0 10 times before returning to 50. If you actually catch a pattern over here, if you are even a least bit good at mathematics, you will catch the pattern over here, right? Let's say the initial condition was 50 right side, so our 1000, right, we will get 1050, and if you divide it by 100 we get 10, and then we do 1050 modulus with 100, right? So we get 50 again, which exists within the range of minus 99 to 99, same as last time, but this time I'm just checking it through this, right? And we also need to make sure that if it's 0, right, the value after that is 0, then we also have to increase the count, so we have to increase the count by 1, right? Now if it's negative, so 50 minus 1000, that's 950, right? This would be in negative, right? So we just need to do this thing instead of the other. Simple as that, right? We get 9, right? Or if it's 0, then we also increment it by 1. Simple as that. Then the same thing as before, we do it by modulus, so 950, right? We get minus 50. Simple as that. Simple as that. Then it exists within the range of minus 99 to 99. Now we can simply just do dial plus 100 just to remove the range stuff, so it becomes for the circular dial of 0 to 99. Simple as that. The algorithm is this much. Now one thing to make sure is that if you start from 0, so let's say your dial ended up at 0, then you minus, like you move to the right by 80, right? this should also, it's also passing through 0, right? So normally with this logic it would count that okay, it's passing through 0. Like if you use this logic, it should go through 0. That means it will increase the count, which we don't want. It was at 0, then it moved. We did not pass through it, we started from it. So that's where the tricky part is. Like if you get through that, then this is easy. This is the algorithm what we are going to simply use. So yeah, let's just make a function and uh, get through, I guess get through passing 0, right? And simple as that, we just say it's a vector string and it's a reference to input data. Simple as that, not that big of a deal. And I guess we just add it over here, right? And answer 2, let's just call it get through passing 0, and then we just pass in the data. Simple as that. Then we show the answer 2. Okay, for this example I think it was 6, right, if I'm not mistaken. Yeah, so for this it was 6, so we want 6 over here, and I shall remove this. And actually, you know what, let me just add something simply known as, let's say, day 1 logic, right, dot txt. Okay, just paste it over here, just call it part2, and then part1, right? So for part 1 it was simply just this. So let me just can I just copy paste it? Nah, not really. Okay, so the logic over here was modulus of 100, right? So the logic was just a dial plus val, then we do modulus of 100. So let me just write that neatly, equals modulus of 100 dial minus val. Actually, let me just add this. These are the small things that we should actually add, you know. I will put it in my repository, why not. This will be within the range of, let me just copy it over here. So this, and then we just simply do this. I could be using NewVim, but I just wanted to use VS Code for this stuff. I don't know why. Don't ask me anything. Yeah, right. So then dial plus 100 means it changes to the range of 0 to 99. Then we just make sure if the dial is equal to 0, then we increase the count. That was the logic last time. This is the logic this time, right? Okay, getting passing through 0. Normally just copy this because we just need that kind of stuff, right? Okay, yeah. Now we just need to make some changes to it, that way it will work without any problem. Let me just do this. Okay, so first of all, as I said, we have to make sure, we do have to make sure that when we start, so if the start of the dial is from 0, is 0, then whether we go left or right, it won't, whether we go left, so after that, if the style is 0, then L or R is not equal to count. This is just whatever I'm writing over here, right? So basically that just means whenever the dial is at 0 and we go left or right, it shouldn't mean that the count should increase. It should not increase. So for that we can simply just add if dial is not equal to 0, which means it's any other number, positive, negative, whatever other than this. And let's say dial minus value is less than 0, is less than 0. Let me just tell you why I added that part. Okay, so if you actually check it, dial is not equal to 0, simple as that. This logic, we don't want the start of the dial to be at 0. Then dial minus value is less than 0. The logic over here is that, let's say if we're going to use example, right? Yeah, example, then starts at 50, as we all know. So 50 minus 68 is minus 18, right? That means the next time it actually goes, like if we just check it, right? If this has not been set into the value yet, right? It's just checking it once. So if it is less than 0, increase the count, simple as that. If it means that 50 plus 68 is 118, right? So it means it has passed through 100 once, but it's in the negative side, so we don't really care about it. So it means we have increased it, so that's why it's there. And just to make sure it doesn't pass through 0, right? Doesn't start from 0, the dial doesn't start from 0. It's simple as that, not that big of a deal, easy, simple, nothing big. So now we just actually do the operation right over here, right? Then we actually check. Okay, so first of all, this really makes sense, right? Simple, not that hard. Got it? Like if it starts from 0, then it's problematic, like really, because normally whenever this is completed, by the time this stuff is completed, right, and it goes to over here, if you're worried about it getting some big value, right, in the dial there's some big value and it will just increase the count by 1 while we need multiple counts, don't worry about it. When it goes to this step, then the modulus step, it means it has rounded up to minus 99 to 99. Then we do that to 0 to 99, so it will never go, the dial will never go into another big number, right? It will always be within that range, so you don't have to actually worry about it. So yeah, so now we can simply just do our, here as I said, we need to implement this logic. We need to make sure that since this has not been modulus, so it hasn't reached it hasn't reached the range of minus 99 to 99, we simply just need to check it over here, right? So simple as that. If dial is less than 0, we do count plus equals minus of dial by 100, simple as that, nothing big of a deal. Or else if it's false, that means the dial is greater than 0, then we just do count plus equals dial by 100, right? Then also set if dial equals 0, we just increase the count, right? We want both for this and that, so 0 modulus, sorry, 0 divided by 100 is 0, that way it won't increase the count, so we just do this step over here just to increase the count. Now simple stuff, we actually do the range, so it comes back to this range actually, right, back to the range of minus 99 to 99. Now for positive, we actually don't need to do this, because even if it starts at 0, uh, even if it like actually starts at 0 and it goes ahead, it just goes ahead, there's no actual problem of getting into the passing through 0 part, right? It won't really, it doesn't really count as passing through 0. When you actually do it, the problem by yourself, you'll actually face this trouble. That's why I was saying this thing, this is a kind of like hard part to get through. So if you don't start from it, then there's no problem, you won't fall into this if you just follow this, but if you do it by yourself you may fall into this problem, right? Anyways, uh yeah, let me just actually quickly wrap it up. So we do the same thing over here, so dial plus equals val, right? After that we simply just do count. Since it's positive, right, means positive, that means there will be no problem of negative signs, so we can simply just do dial by 100, right? Simple as that. Then we just actually check it once. I didn't want all of this, I forget, does all that, right? Dial equals 0, that means we increase the count, right? And then we simply just same thing, we simply just round it back to this range, and now this means that it will go back to 0 to 99 range. Now it should normally work without any problem, right? I guess this is showing a problem because it's a copy, right? So if I just call it line, will it go away? Yeah, it went away. Don't worry about it, it's just saying that okay, why are you creating a copy? We don't really want a copy every single time, right? Because we passing input data into this, and it should be a reference, right? Every line should be a reference, or every input data should be a reference, to be honest. It came as a reference, it shouldn't cause any problems, it should be correct, but it's just the compiler saying, and small optimization that doesn't really even matter. So now if we do this we should get 6, and that is what it was over here, right? So now we just simply check it for our input.txt and it should be okay. Input.txt, right? And it gave 5963, which if we actually check is correct, right? So I will do the, yeah, I will do the second video tomorrow or sometime later on, don't worry about it. And this question is simply just to check repeating digits, so like this, in over here you can see that there's a 5, there's a 5, there's 888811, can be easily solved through a hash map, because let's be honest, it's every string, I will keep it as string, I will not convert it into integers, there's no really any uh, way of doing it, right? And then this also it's kind of so yeah, okay, valid IDs are also there, so we don't really care about those kind of stuff if the first one is this, right? Okay. And okay, 55 64 twice, meet our sequence pattern second file by looking for ID which is made up of some sequence of digits repeated twice, so 55, okay. So if you actually check 1 2 3 1 2 3, it should be even, right? Simple as that, it needs to be even, like if there's a odd count then there's problematic. So we can simply use a hash map or a simple counting stuff, but counting would be better really. We just check if there are the stuff in it, right? So if there's one, yeah, okay, yeah, sure, as simple as that, we just check it. Okay, I need to think of an optimized method for it, right? If you do the unoptimized method is simply just hash map or and set, actually set would be nice. So a set, then you just count it, or make everything into an, so 11 to 22 means every number between 11 to 22, right? And you simply just I guess, yeah, you just do one square loop and then actually check it out. So for every digit within this you just go through it and do it, Actually, that would be a very high complexity stuff. But yeah, if we are doing it unoptimized, so I have to really think about it optimized way, right? Let me just check it out. Yeah, okay, yeah, that's problematic. Yeah, sure, I will do that. Yeah. So this is the range basically, right? So you can store this in a 2D array. Yeah, 2D array should be fine. So storing it in 2D array, then we just know the range and everything, or we can use pairs. Pairs would be a little bit inefficient, I guess. Yeah, 2D array should be fine. Okay, yeah, I will do this and I will give this to you later on, guys. Thank you for checking out this video if you did, and subscribe, like if you like it. I don't know, guys. Bye bye.